So in this example, we see we have a simple circuit that has a independent voltage supply, but then it has a dependent current source. And it's a current controlled current source controlled by this current, or a factor of that current there. And they've asked us to calculate what the voltage across this resistor here would be. So let's see what we need to do to figure this out. So the first thing we want to observe or look at is this resistor. And we can recall that Ohm's law is equal to VIR. So in this case, we know the I, or the current's 19I. We know the resistance, 10 ohms. And because the current is flowing in the opposite direction, or if we take the direction of the current flow, we see it would hit the negative sign first. So it'll be a negative 10 times 19I. And when we calculate that out, that would be 190I. All right, so that's what we get from just applying Ohm's law to the resistor itself. So the next thing we can do is take a look at this node and do a nodal analysis on the current. So when we do that, we see that we have 19I coming in from one direction, and I coming in from the other. So if we sum these up, then the current, and we'll just call this 2 ohms, through the 2 ohm resistor is going to have to equal to 19I plus I, which would be 20I. So that's what's flowing here, is 20I. So finally, we want to take a look at this voltage loop here. So we'll do that here. And so as we do that, we see coming across this first, we'll go in this direction. We see we have the 100 volts. Then as we come around, this is a short circuit, so the next thing we encounter is our 2 ohm resistor. And because of the direction that we have assumed all the currents, this will be positive, so that's going to be plus 2 times 20I, so that's resistance times the current. And we sum that up and it should equal to 0. So now we can solve for this, which would be 100 is equal to minus 40I, or I is equal to minus 2.5 amps. So we've got a value for I now, and I forgot my minus sign there. So now we can take this number and plug it back into this value here. And so when we do that, we have minus 190 times minus 2.5. And when we multiply that out, the negatives cancel and we get 475 volts. So this is the voltage drop across that resistor.